Hello and welcome back. These will be the notes for section 4.4, finding slope and rate of change. There is a PDF available if you'd like to download it and follow along. First thing we'll talk about is slope. Slope is simply the ratio of the vertical change, which is called rise, to the horizontal change, which is called run, between any 2 points on a line. The letter M is used to indicate slope. So anywhere you see an M, we are going to indicate slope. You'll see it down here as well, M. If we look at our picture over here, our graph, we actually have 2 points. We have a point down here and a point up here. And slope is really the rise over the run, the vertical change over the horizontal change between 2 points. We'll call them point 1 and point 2. And the way you calculate a vertical change, also called rise, is we subtract. So slope is really change in y, which is a subtraction problem, over the change in x, which is another subtraction problem that will give us a horizontal change or run. So the slope formula is y2 minus y1 over x2 minus x1. The most important part of this is that you got your y values on top and your x values on the bottom. The y2 doesn't have to come first. You can put y1 up front. However, if you put y1 up front, you also have to put x1 up front. Otherwise, your slope will be incorrect. Example number 1, we want to know what is the slope of the graph. We've got 2 points, -4, 2, and 6, 2. So M is going to equal, remember it's the change in y over the change in x. So I'm going to start with the 0.26. That's going to be my y2 and x2. So 6 minus 2 over 2 minus, and that's a -4, so I have to put that in parentheses. So we end up with 6 minus 2, which is 4. And 2 minus -4 is 6. This whole thing is equal to M. And 4 over 6 can be reduced to 2 over 3. So a 2/3 slope. Now if we look at the picture, we'll notice that we actually go up 4 and over 6. Rise 4 and run 6. So this is a positive slope. But if I reduce it, it's up 2 over 3. So if I go up 2, so 1, 2, and then over 1, 2, 3, you'll see I land back on the graph again. So up 1, 2, over 1, 2, 3, and land back on, up 1, 2, and over 1, 2, 3, and land back on. So slope is a way of finding points on your graph once you know where one of the points that exists on the graph. So the slope here would be 2/3. Example 2, what is the slope of the line that passes through those 2 points? Again, it's just going to be change in y over change in x. So M, which is our slope variable, is going to equal the 6 minus 3, so 6 minus 3 over, I started with the 6 last time, so I got to start with the 4. 4 minus -2, so 4 minus -2, and we end up with 3 over 4 minus -2 is 6. So I can go up 3 over 6, or if I reduce it, and that's usually how we have it as in our formulas or our equations, is in reduced form, I can call it 1/2. So up 1 over 2. Keeping in mind that the variable M represents slope. Example 3, this one looks to be a negative because the line is going down to the right. And I'm going to actually calculate this one right from the graph. Okay, we can see that it's down 6 instead of up. So that would be negative. So M is going to equal -6 over +3, which is going to reduce to -2, 2 over 1, which we can just call -2. When we go to graph these, we find a point. If we see a slope of -2, and we know it's supposed to be rise over run, we then go back and put a 1 underneath it, so we have a rise in the numerator and a run in the denominator. Example 4, slope of a horizontal and vertical line. Okay, so we got a horizontal line right here, so we're going to calculate its slope first. And again, it's still just going to be change in y over change in x. So the y values are 4 minus 4 and 2 minus 4. So 4 minus 4 is 0 over negative 6. Well, 0 over negative 6 is 0. So a horizontal line has a 0 slope. On a vertical line, we still have m equals. We have our fraction bar, and our y values are 5 and 1, so 5 minus 1. And then our x values are 3 minus 3, which gives us 4 over 0. Well, you can't divide by 0. So what we say about the vertical line is that its slope is undefined. We cannot divide by 0, so we say that slope is undefined. So here's the classification of lines by slope. You can see that if it goes up and to the right, m is bigger than 0. We call that a positive slope. If it goes down and to the right, we say that m is less than 0. That makes it negative. We have a negative slope. If it's flat, horizontal, this is a 0 slope. And if it's vertical, it is undefined. Rate of change is another way of expressing slope for situations not directly expressed on a coordinate plane or an equation involving x and y. However, it is still a ratio of two values. Ratio of two values. And sometimes we do have to find the difference in our values. The table shows the distance a person walks for exercise. Find the rate of change in distance with respect to time. Now we do know it's going to be a ratio. The question is, what goes in the numerator and what goes in the denominator? Well, since they're saying distance first with respect to time, then that means I'm going to have the change in distance over the change in time. Okay, so we're going to go ahead and pick two values. So we'll do the change in distance. Distance is here. Let's say I do the 3 and the 1.5. So I have a 3 minus 1.5, and the matching 3 was 60 minutes minus 30 minutes, and we end up equaling 1.5 over 30 minutes. And since this is a rate of change and we have a decimal inside of our fraction, we're actually going to go ahead and divide it out. And when we divide that out, we end up with 0.05. And this is miles on top per minute. And that's the rate of change. So the person is walking at a rate of 0.05 miles per minute. Example number 6. Community theater performed a play each Saturday evening for 10 consecutive weeks. The graph over here shows the attendance for the performances in weeks 1, 4, 6, and 10. Describe the rates of change in attendance with respect to time. We are going to find the rate of change between week 1 and week 4, and we will place that here on week 1. I'm not sure why we got that as week 1. But anyway, we're going to do a change between the attendance, because it is asking the rates of change between attendance with respect to time. So the attendance from 232 minus 124, and that gives us a 108 change in attendance, and that is over week 4 to week 1, so that's 3. So 108 over 3, and that gives us 36 people. We're going to call it people. Yeah, we'll call it people. People per week. 36 people per week. During the second week, or week 2, whatever we want to call it, the change went from the 232 down to 204. So 204 minus the 232, and that gives us a negative 128 change. That means it went down. And that was from week 6 to week 4, week 4 to week 6. So that's 2. So we're going to put a 2 on the bottom. And that will end up giving us negative 14 people per week. 14, negative 14. So attendance went down 14 people per week during that duration. And then we went from 204 down to 72. So 72 minus 204. That leaves us with a negative 132 over, and that was between weeks 6 and 10. So 10 minus 6, it gives 4. And when we divide that out by 4, we get negative 33 people per week.